guys, welcome to Rain's Physics. Today we're going to talk about the charge of an atom, the charge of an electron, charges of protons. What is the values? How do they interact? And what will affect the forces that are going between them? Let's get started. So when we talk about the charge of an atom, the first thing that comes up is protons and electrons. Most of you will remember that the charge of an electron is negative and the charge of a proton is positive. However, you may not have been given the actual values for those specific subatomic particles. You may remember that a neutron is neutral, it has no charge, and they have masses, and you may know that an atom will lose its charge or gain its charge based upon where the electrons go. So when we're looking at an atom, and you start off with a neutral atom, if I take away an electron, you will see that it gets a positive charge. That's a cation. And if I add an electron, then you will see it gets a negative charge or an anion. So because of the proton and the electron, we have two types of charges. We have a positive charge and a negative charge. When we're looking at those, they have forces that go between them. There's an attractive force and a repulsive force. So when we're talking about protons and electrons, you may remember that they attract one another, and that's the attractive force. But like charges, proton and a proton, or an electron and an electron, they are going to repel one another. And so that is the two types of electrical forces. So you know that they're positive and negative, but what is the actual value for those charge? Well, Robert Millikan did an oil drop experiment to determine that. If you'll take a moment and check out this link right here, that'll take you to Tyler DeWitt's channel, and where he goes over it in detail, just perfectly, how they found out the charge and how they came about this charge. But the charge of an electron or a proton is going to have this elementary charge, is what we call it, and it's 1.6 times 10 to the negative 19th coulombs. And that value is going to be there for every single electron or proton. Now, an object may have a charge of 2e, 3e, 4e. That just means that it has that charge. Two protons would be 2e. If it has two electrons, it would have 2e. And so that's the elementary charge, and that's what the E stand for, is 1.6 times 10 to the negative 19th. Now, when we're looking at a proton, the proton is a positive, whereas the electron is the negative. And then you have the neutron, and it's neutral. However, each one of them have their own mass. Okay, now we want to talk about the forces between two different charged particles. We've talked about them being attractive and repulsive, but what if we wanted to quantify that actual force and find out what is the force, the actual numerical value for the force between those two particles? And this is the equation you need, Coulomb's law. Force is equal to K, which is Coulomb's constant, times the charge of 1, Q1, the charge of 2, Q2, so you got Q1 and Q2, and then divided by the distance between those two charged particles, which is R squared. And that is going to be the Coulomb's law equation. Now let's look at this diagram, or this example of this taking place. Notice there's a distance between these two particles. There's a force given at the top. They both have the force on each other. The arrows are directed inward, so that means they are an attractive force. If the arrows were directed outward, they would be a repulsive force. And this is how we determine what is the actual quantitative value for that force. Now let's solve a problem using Coulomb's equation. One of the standard problems that we always talk about is if you take a balloon and you rub them on your pants. This problem here is going to ask you rubbing a balloon on your pants. The balloon now has a charge, and the pants, the denim jeans, have a charge. And they want to know what's the force going to be between the balloon and the denim pants. So first thing we need to do is write down all the things that we know. And so here's your problem. Looking through that problem, you should be able to write down what you know. And here are the things that we know. If you look there, we identified that the charge on the genes is going to be the same value as the charge on the balloon, just opposite. One's positive and one's negative. And so that's a very important thing to note. That's due to the conservation of charge. If you pull charge off of one object, then that means what was behind, like the charge that left an object would go to the other object. So the charge is not created or destroyed. And so that's where we got that value. You can see the distance between them two is in there. And now they want to know, what is that force? Don't forget Coulomb's constant in that equation. And let's go ahead and, now that we have these things that we know, let's plug them into the equation. So here's the equation for Coulomb's law. Now that you see that equation, let's plug the numbers in that we know. So let's go back and look at what we know. And now we plug in the numbers to where it would look like this. Once you plug that into your calculator, you can use Desmos, or you could type it into a graphing calculator of any kind, or a scientific calculator. You should be able to get a result of this. Now, we said that that value is attractive. And that's because the Q's were positive and negative. If the Q's were both positive, that would be a repulsive force. If the Q's were both negative, that would be a repulsive force. But because they are different forces, different charges, they will have an attractive force. And that's how we solve for a Coulomb's law equation. Next time you have any questions, please reach out. I'm always available to help you. Have a fantastic day.